Okay, so just scroll down there, and we're on part B here. I just erased what I had up here for that question. Write an expression in simplest form for f divided by g of x. So we're dividing both functions here. We have 2x squared minus 13 minus 7. It's going to get divided by 2x plus 1. This might be a clue as to what this might factor. We're going to have two brackets on top, and we're going to get the 2x plus 1 below. We can do a guess and check. This is a prime number. We can do a guess and check in the sense that that has to be 2x, this has to be x. Otherwise, you're going to have to think. Normally what we do from grade 11, if you remember, we multiply these two numbers to get negative 14. So it's factors of negative 14 that add to negative 13. That add or sum to negative 13. Okay, so that would have to be negative 14 and positive 1. They multiply to negative 14 and they add. The trick here is to replace, it's called replacement. We'll replace negative 13 with negative 14 plus 1. So this is just a little bit of a review. We go back and we write the whole thing, and instead of negative 13x, it's negative 14x plus 1x. You might want to just put that 1 in there. And then we have the negative 7 from here. We factor these two terms and these two terms separately, bringing out a 2 and an x. Usually it's always something with x, leaving x minus 7 behind. And here brackets are going to be both the same, if you remember. So this has to be x minus 7 as well. So what have we factored out of this? It must have been positive 1. Don't forget this sign, okay? You need to keep this sign. So the final step here is that you're going to get two brackets. We've got one already, the x minus 7. The other bracket is always this with the term there. So in other words, it's 2x plus 1. So we suspected correctly. So this is going to be 2x plus 1, and that's 7, x minus 7. So you could have guessed and checked what those two values could have been. That's positive, okay? Sorry about that. Okay. So there's going to be state the domain, so we've got to put a restriction that x cannot be equal to what? Have a think. X cannot be, well, this can't end up being, this 2x can't end up being negative 1, so if x was negative a half, that's what would cause the bottom to be 0. So it can't be negative a half. That's the restriction. It's also basically a way of stating the domain. Your textbook will give the answer slightly differently. Typically it will write it in curly brackets. It will also state after this that x is a member of all real numbers. So everything else apart from this number, negative a half, is an option. Okay, we have to also simplify this because this and this can cancel, leaving x minus 7, which mimics, again, a linear function with slope 1 crossing the y-axis at negative 7, but there'll be a point of discontinuity when x is negative a half. A circle. Explain two different ways to evaluate f over g of 3. In other words, we're replacing x by 3. So notice we have it already solved or simplified, but we're putting in 3. 3 will go in here. So explain two different ways to evaluate. So that's one way. We can just simply take x minus 7 and say, okay, that's going to equal 3 minus 7, or negative 4. What's another way? What is another way of evaluating that? I guess we can start right back here with our original expression and input x to be 3 here and 3 to be 3 here, and then just solve or simplify. You will get the same value of negative 4. So let me just scroll down here. Okay, moving on to example 3, the last example. Consider these two functions. We can see right away that there's restrictions here and here. State the domains. So for f of x, for this one, x cannot be 1. So here x cannot equal 1, and for this one x cannot equal 3. Evaluate 3 times f times g when x is 2. We're going to multiply these two functions together and then multiply by 3 and put in 2 for x. We can actually put in, we could cheat I guess, we can put 2 in here and here, find the values of each separately, and then multiply 3 times the values we get, one for f and one for g. Well anyway, let's let's write it all as one single thing. We're going to get 3 times 2. I'm going to just slip in the value 2 for x. So I'm writing function f here, 2 minus 1, times function g is going to be, again, 2 for the value for x, and 2, I really should be consistent in writing brackets around all the x values. So what does that equal? It's going to be 3 times 4 divided by 1, so 4. 2 divided by negative 1. 2 divided by negative 1 is negative 2. So that's 12 times negative 2 is negative 24. Okay, so any restrictions? We've mentioned those. Anything else we haven't thought about? Not really. So that's us. And then part C, we're going to write an expression in simplest form for f plus g of x using both of these. So we're going to add these two functions together. So let me pause. Okay, so if we write these functions down, f plus g of x, it really means we've got 2x over x minus 1, and we're adding x minus 3. Okay, so simplifying that, we have to have a common denominator, so simply multiply the denominators together and we'll get, since really we're multiplying this by, oops, sorry, this should be a 3. Since we're multiplying this bottom by x minus 3 to get that, the top has to get multiplied also by x minus 3. It's a plus sign, so put a plus here. This bottom, to get a common denominator, was multiplied by x plus 1, so we've got to do the same to the top here. We're going to take x and multiply it by x minus 1. Alright, simplifying that, basically we get the following: 2x squared minus 6x plus x squared minus x, all over a common denominator, x minus 1, x minus 3. Okay, continuing on down here, simplifying the top, we'll get 3x squared minus 7x, all over a common denominator, x minus 1, x minus 3, and that's equal to, now we're going to factor, so let's see if we can cancel. If we can factor the top, maybe it cancels with one of these items on the bottom, and in fact if we bring out an x, you'll see we get, what do we get, 3x minus 7, Maybe it doesn't factor, or maybe it doesn't cancel rather, but it certainly factors. Now, I think that's as far as we can go as far as simplifying it. So what are they asking us? Write an expression in simplest form. So we've done that. State any restrictions on x. Well, we've got to just be careful. We have to sort of watch what we're doing as we go along. We haven't really changed the denominators. So it's not a division, or we haven't had to flip anything. So our denominators have stayed the same in both cases, and still the restrictions are x cannot equal 1 or 3. Okay, lastly, write an expression for the simplest form of f divided by g of x, state any restrictions. So, it's the two functions. So, really, if we've got a division such as 2x divided by x minus 1, dividing, then really, since this is a fraction, the second one is a fraction, typically when we have a division, two fractions, we flip the second fraction and make it a multiplication. So multiply by x minus 1 over, x minus 3 over x. Alright, now be careful, there's going to be the restriction here of x cannot be 1, x cannot be 3, but now notice what we have over here. This is a different denominator. That also cannot be 0, so x cannot be 0 as well. So we're going to have three values, or three restrictions. So why don't we just write that over here for now? X cannot equal 0 because of this, 1 or 3. Okay, let's carry on with our multiplications. We're going to get 2x times x minus 3 all over x minus 1 times x. Okay, can we cancel? Well, we can cancel that x right here with that x there. Looks like this now equals 2x minus 3 over x minus 1. And that's the simple. Oh, have I made a mistake? No, that's about it. You can either write it like this, or you can just multiply out the brackets as well. 2x minus 6. Either way, that's your answer. Okay, so assignment questions. You want to finish up to all of the questions up to 11, and we'll see you in class tomorrow.